Hi, Nikon D50 Teardown and Review Part 2, electronics this time. Let's take a look. This is always my favorite subject. There are 5 boards within this camera plus the sensor. Let's see what they do and then I will show you the most common problems. Mainboard and sub-mainboard. And here is, right away, something that I don't like to see in cameras. This hard, non-flexible board-to-board connector between them. In case of any even minor impact damage, either one or both of these connectors will get detached from the board, often causing a lot of damage. In some cameras with thin plastics, this can happen without any impact. Quite often, it's very hard to repair this kind of problem and rebuild traces, so either one or both of these boards have to be replaced. And this can be expensive. There is no such problem with flex cables. I'll talk about this in future videos. Canon 6D, for example, has an interesting solution to this problem. Anyway, these 2 boards control most camera functions. Buttons, motors, position encoders, focus adjustment data is here, and part of firmware is also located here. Flash board. This is the main igbt transistor. Flash capacitor. These rarely fail. The flash controller chip is located on the main board in this model, which is a bit unusual. And there is a fuse over here. Power board. The main fuse is here, power management chip, and a bunch of caps and inductors. Again, it's a power supply that creates many different voltages for the entire camera. 6 megapixel CCD sensor. Yes, it's CCD, not CMOS. Also, it has a built-in electronic shutter, so this camera works slightly different than most other DSLRs. The mechanical shutter is more like a sensor dust cover. If you set some higher shutter speeds, the electronic shutter takes over. One huge advantage is that you can sync your flash or strobe at extremely high speeds. And some people use this camera just for this reason, so if you need a cheap $50 to $100 Nikon DSLR with electronic shutter, this could be a good one. And as with most sensors, there is a low-pass filter on top of it, the real sensor is on the bottom, and there is a rubber seal between these 2 pieces of glass. Okay, now let's take a look at the digital board. So this is the part where all digital signal processing is happening. And this is probably the most important part on this board, the main processor. It's like the one in your PC, except it has a bit more functions and is application specific. This part does all the JPEG compression, white balance adjustments, all in-camera effects, noise reduction, etc. It's directly connected to RAM memory, SD card, USB socket, and some other things. Next is RAM memory. This is 256 megabits SDRAM memory, or otherwise 16 megabytes, and it's running at 166 MHz. It's exactly like a RAM memory in your PC. There are 2 identical chips like this on this board, so it's 512 megabits or 32 megabytes. Not a lot in case of this older camera. And it's dual channel. Having 2 smaller chips instead of 1 large simply makes accessing the memory faster. Again, exactly as in your computer. Some cameras have 4 or more memory chips. Moving on. Next is 16 megabits or 2 megabytes flash memory. This is like a PC hard drive. Here is the larger part of the firmware, all of the menu graphics, some of the CCD or CMOS adjustment values, and lots of other things. ADC. This one is a bit more interesting. It's a 12-bit analog to digital converter, with many other functions necessary to process a CCD signal. So analog signal from the sensor goes to this chip, and the signal processing starts here. This is correlated double sampling. Sounds complicated, but the general idea is that it compares black pixel signal level to the readout from an actual exposure. And this is because the signal level from a black or dark pixel is not 0. It always has some value, and this value can change with temperature, for example. So it makes sense to subtract this dark signal level from the actual exposure. Next in the line is PGA, which stands for Programmable Gain Amplifier. And you know this one very well, even though it sounds a bit unfamiliar at first. This is your ISO, right here. It amplifies the signal by a value it gets from here. And this is a serial communication port connected to the mainboard. Here is how this works. You set the ISO number, the microcontroller calculates a specific gain value and sends it here through this serial port. Then, the next several millions of pixel signal levels will be amplified by this specific amount. And this gain can be adjusted using 10 bits. So 10 bits is 1024 possible combinations. So you could easily have 1024 ISO steps. Of course, it wouldn't make any sense, so you have only like 10 or whatever, depending on the camera. Okay, after amplifying, the signal goes to 12-bit analog to digital converter. 12-bit means 4096 possible combinations. So in other words, whatever the signal value is, it will get assigned a number between 0 and 4095. The interesting thing is the difference between 12 bits and 14 bits that many cameras have these days. It doesn't sound like much, but with 14 bits we have over 16,000 possible signal levels. Okay, and there are also some other things going on within this chip specific to CCD signal processing. Here under the memory card slot there is the second SDRAM memory chip I mentioned previously. Now, let's quickly go over some of the most common problems. Non-flexible board-to-board connectors. I always check them carefully, even if it doesn't seem like the problem is related to this connector, and resolder in case of any doubts. Flex cables. Always a good idea to clean them and check for any damage. These can be tricky at times. Motors. When motors go bad, they often get shorted internally, or they work and stop suddenly from time to time. You touch them and they work again for some time and stop. Power board. The main fuse is here. Inductors and capacitors rarely fail in DSLRs, but I check them quickly before throwing away a power board and replacing it with a new one. Much higher failure rates in point-and-shoot cameras. MOSFET transistors. Also a quick check in case of any problems, but overall I don't spend much time testing everything on power boards, just replace them. Motor drivers. When a motor gets shorted internally, it occasionally blows up the motor driver. Sometimes there is a big hole in this chip. Flashboard. The main fuse, which is here, the igbt transistor, I check it for shorts, and sometimes some other obvious things. Digital board. All kinds of connectors, USB, HDMI or any other type, SD or CF card slots, especially CF, broken or bent pins. SD card switch and all solder joints, I check them very carefully in case of any intermittent memory card problems. These are the most common problems. There is a lot more, but honestly a large part of my job, at least when it comes to electronics, is just checking for these super simple problems. Tough problems are way more interesting. Okay, I hope you enjoyed it. The next part is gonna be about the shutter and the mirror box, and most common problems with these. If you have any specific questions related to the mirror box, the aperture assembly or the shutter, let me know in the comments below. See you next time. Bye.